All right, well, let me introduce this Bronco, and you guys feel free to contribute, and don't worry about the cameras. And so I want to talk to these guys first because they're going to be watching this. This will be future classes, maybe you guys later. This is the Ford Bronco that we did the distributor on probably about 5 or 6 weeks ago. And the owner of the vehicle said that the that the Bronco ran beautifully, better than it ever has in the 3 or 4 years he's owned it. And that makes sense because the timing was off, the spout connector was unplugged. And anyway, I'm here at the school, and I'm actually substituting for our brake and suspension class, and I have a mix of students in here. I have 5 of you or so, 6 of you that have had my class, and then I have about 5 or 6 that are brand new to our program. Haven't had basic electrical yet, right? You guys have not had basic electrical. You've only had the brake and suspension class. So this might be a little bit challenging from a standpoint of where do we go? How much do I give you? How much can I give you that even being a rookie, you can absorb this information? That's kind of my focus for you guys. And even though the rest of you that have had my class might feel maybe that's too basic, I think you would benefit from it too. So I have no idea where this is going to go. I hope it's something stupid and we can show all of it, start to finish. Well, we're going to do that anyway. But we have a no start, and the only thing that I've done so far out in the parking lot is I actually used one of your pocket knives to check for spark. I needed something metal to put in the plug wire. And the weird part is before the vehicle was cranked, I got shocked on the tip of that blade. But when we cranked the engine, there was no spark. Okay, so behind me I have another camera feed going. This is actually live. This is the underhood of the vehicle. This is a 5.0 engine for those of you that didn't follow the beginning part of this series. There is a 2-part that, I don't know if I mentioned that, maybe I did. There's a 2-part series that I have already completed and uploaded. That was when this vehicle was in here last time. It was a really great case study. It ultimately was a faulty pickup in the distributor, okay, that was keeping this vehicle from running properly. Really weird design that this uses, and it is an unusual type of condition that this has, and so I really wanted to record it. But it's back, and we have a no start again. I'm going to start from square one, which is a basic spark test, and this is something that any of you guys can do. So you guys can look up there. All I've done so far off camera is I've just installed a inline spark tester that you can see an air gap right here, and I have that going directly to the coil. So this is coming from the coil, and then I have the alligator clip going into the distributor cap. I don't have to do it that way. There's another way you can do that. We can go to, say, a known good ground. If I go to that screw, I just connected that to the throttle body right here onto that screw, and I can do it that way too, again leaving an air gap. Can I check for spark that way? I can. So you don't need much on electricity to know that we could do it either way. This spark is looking for a ground, for lack of a better term right now. We'll just leave it at that. It's looking for a ground, and that ground can be on the block itself or into the area where it normally goes, which would be on the distributor cap. Okay? Here's why I choose, when I do no spark diagnosis, this is any car, this is a universal concept. Why I choose to go to the location of where the spark normally goes is cylinder compression. Listen carefully, this is difficult. Can be difficult if you're not focused. Cylinder compression makes it difficult for the spark to jump the air gap. So I'll say that again. Pressures in the cylinder affect how much energy it takes to jump the gap. So for example, a cylinder that has no compression, that spark plug fires very easily. A cylinder that has good compression, it takes a lot more energy built up in the coil to overcome the air gap and surge across that spark plug. This is why when you supercharge an engine or turbocharge an engine, you need to modify your ignition system. You see guys putting MSD systems in cars because they're high energy, because you need higher voltage from the coil to overcome the increase in pressures that you made on the engine. This is just a basic fundamental of spark, okay? So why am I choosing, question for you guys, and you new guys can answer too. You should be able to. Why am I choosing, when I do this spark test, to go to the area where the spark would normally go rather than to ground? What's that?
Is that because it's where it's going to be at? Or do you want to test where it's going to be?
Where it's going to be, yes. That is one reason. I want to do it in its natural environment. That's where the spark it would normally be. But we can do it both ways. I want to be clear about that. We can go to ground. We can go to the distributor cap. But I choose this path because it's harder for the spark to go on this path than it would be if I went straight to ground. So what I'm doing is I'm stressing the coil like it should be. In a natural state, in its normal direction, I'm stressing this coil. If I put this alligator clip here to the block, I'm taking away that stress from the coil. And so what I'm telling you is on certain vehicles, you can think that your spark is good when you go to the block, but when you put it to where it normally would go, the spark is very weak and erratic. So that's why I'm choosing that. So there's ways around that. If I wanted to go to ground, and sometimes I have to, what I would do, I have this air gap set to about 20,000 right now. If I was setting this to ground up here, I would take that air gap and move it to 40,000. Now, why would I do that? I want to stress the coil more. It's not good enough to just check for spark with a small air gap. We need to have a wide air gap, stress the coil. Make sense? So this is a coil stress test is what I'm doing. It's really twofold. I want to see spark. I want to see what that spark looks like, okay? I have the key on already. I'm going to show you one other trick to working by yourself. And this is unique to this design. We can't do this on every system, but I want to show it to you. Unique to this design, Ford uses a starter solenoid right here on the inner fender. When you crank the engine over on this vehicle, what it does is power, let me move this out of the way. Power will come into this lead right here. Power will come in here from your ignition switch, and it will energize a coil inside of here that makes a magnetic field, and it will connect this big post to this one. And when it connects these two, it cranks the starter motor. So the starter is on this wire. This one's hot all the time, and this one would be hot when I crank it inside the car. So what I can do when I'm working by myself is I can take that off, and you could actually just use a screwdriver. I'll show you real quick. This is not the preferred method, but if I connect with this screwdriver, between this one that's hot all the time and this one, watch what happens. That should not keep cranking. I can't stop it. I can't stop it. Okay, good lesson there. No, listen, when we worked on this last time, I remember this thing continuing to crank sometimes when we let off the key. Do you remember that?
I do remember.
It wasn't like that. I was a little panicked there for a second. And this is what happens when you film live. Did you see how I unstuck that? I just smacked on it with a screwdriver. That shouldn't happen. And I don't know why that happened now as opposed to the key. That's going to be a concern the rest of the way through this.
If you was taking a negative off the one that would have stopped it?
I could have taken the negative terminal off of the battery, but by the time I would have got tools and had that off, that starter would have been baking.
Oh, okay.
So there, knowing the design of this was important to know that when I took that control wire off, that there was no ignition feed going in there. There's only one possibility, and that one possibility is those contacts stuck. I'm going to try it one more time, except I need the key on. I forgot to mention that. When I do this test, I don't need the key on to crank the engine over because this one's hot all the time. I can just jump the two together. But the reason that I turned the key on is I need the ignition system to be active. I need the ignition system to be alive. I need power to go where it normally would. I need the engine computer to be alive. I'm doing a no-start diagnosis, and so I need that to be active. One more piece. really important, especially for you rookies. If this is a manual transmission and I'm in gear and I have the key on and I crank this over manually, what's going to happen? It's going to run me over. I'm going to hurt someone. I could kill someone. So I probably should have led with that this isn't like the safest thing to do. This is a automatic transmission. We don't have an issue with that. We are in park, right? Emergency brakes on. We're good. Anyway.
It was a high idle too.
Yeah, it was cranking pretty fast. Yeah. I'm going to try it again. I'm not going to panic this time. I'll smack on it if it sticks again. Here's the thing. When it comes to troubleshooting, aren't there unexpected things that you run into? So we're going down this road that I said we didn't have spark. I don't know if, well, I didn't have it focused on the spark tester. I didn't see spark. I'll get the camera turned back over in a second. We're doing a no spark diagnosis. Does this problem have anything to do with that? No. So you need to know when to proceed. You need to know when to back up and go a different direction. We have a separate problem. Would you guys agree with me on that? Yeah. We have an issue with this solenoid. It just really needs to be replaced. That shouldn't happen. I'm going to try it again.
We discovered you have no survival skills at all, too.
I have no survival skills? Why is that?
You just like ran in circles for a second.
I think I did okay. I mean, right?
As the truck comes at you, you're just like,
Hey, in that moment, Randy, in that moment, teaching is secondary to, I need this starter to stop. And so your mind's, how can I make this stop? So what I did you see me connect the wire back up to this? Well, I'm thinking, I don't know why, but maybe if I get this circuit intact, any leftover voltage or energy in that primary circuit, I can dissipate it. That was my first thought. Second thought was, I'm going to go inside, shut the key off. That was just on a whim thought, because that has nothing to do with this. Third thought was what? That's sticking. How fast did I go through that progression? Come on. That's where my mind was, and you say that my survival, I think that was pretty damn good. On camera, with 2 cameras rolling, and 6 rookies in here watching me like, oh, I got to go to this guy's class? All of that's going on in my mind. Okay, not going to panic. Between the two, that's what I wanted to show you guys in the first place. Okay? All right, look. I'm going to use this. This is a tool that that I would recommend you guys have in your arsenal of tools. Doing what I do, mobile diagnostics, I get asked a lot, what tools should I buy? This is one. It's just an inexpensive jump starter. It's just a heavy duty switch with 2 connections. So I'm going to use this to be my diagnostic aid. Instead of having one of you guys get inside the vehicle and crank it over, I'm going to use this. So one lead will go to my control pin, comes from the ignition switch. Where's the second lead go? It needs to go to power. Can I go to battery positive? I can, or I can go right to the battery positive terminal there, and then when I hit the button, good? Okay, so now we do our no spark test, or I say no spark because I didn't see spark in the parking lot. This is our spark test. We have an engine that doesn't start. We're thinking of 3 main things. You rookies, don't answer, you guys that had me. What are my 3 main? You may not know this, so it's okay if you don't.
fuel, air, and spark.
Fuel?
Air.
Let's see, air. Yes, the air we can, I'm going to rephrase that for you. How about fuel, compression, and spark? The air is going to be there. You could think of a scenario with a plugged air intake and a plugged air filter. I've seen that before. I actually have an image in my textbook in section, what chapter is that in? It's on mass airflows. In fact, I'll put that image right there. There it is. You guys can't see it yet. What you're looking at is an air filter that came apart and was actually over top of the air intake tube and was restricting the air. So you can have an air situation. But the 3 main things we're thinking of is spark, fuel, compression. We need all 3. And so our first one we're doing is spark. It's just easy to get to, that's all. And we kind of know a little bit that didn't have spark in the parking lot. So very important with this test that my key is on. A couple things I'm looking for real quick with the key on. Looking for a check engine light. I do have one. That just tells me my computer is most likely alive and talking to us, possibly. It's not a foolproof test, but just something I'm looking for. So key is on, and then what I want to do is use my little jump starter, and we'll watch this gap. Again, why is the key on? If I use my little jump starter, I can crank this engine over, right? But nothing's gonna happen unless I turn the key on. I need everything to be active, so key needs to be on. All right, so watch it. What do we got? Nothing. So now what I'll do, I'll close this air gap, put it to the same spot, watch it again. Nothing. So is there any reason to check fuel pressure at this point? Any reason to check injection pulse? Any reason to check compression pressures? I don't think so. Can you? So you smell fuel, that's an indication of what? That's a good guide too. Fuel pump's probably turning on, but that wouldn't make fuel smell come out of the tailpipe. For you guys that haven't had my class yet, an electric fuel pump, when you turn the key on or when the car's running, the fuel pump's running all the time. I can actually take this system and manually jump the fuel pump, make it run continuously with the key on. There will be no fuel that goes into those cylinders because we have normally closed injector solenoids that the computer's got to turn on to make fuel go in the cylinders. So it's more than just the fuel pump.
So that means the injectors are still
That means
firing?
my injectors are still firing, which tells us what about our input on this system. So for you new guys, our systems work with inputs and outputs. I'll relate it to a PlayStation controller for you. How's that? Playing a video game, let's say you're playing Madden football, you want to throw the football, what do? You can't just wish it to happen, right? You need some input to happen for that to happen. So what's your input on the PlayStation? X, right? Tap it, he lobs it. Hold it in, he fires it, right? So it's an input. We have an input for this ignition system. It is a pickup inside the distributor. It has to create a signal that the computer can see, and then it turns the coil on and off, gives us spark. The only reason I'm asking you guys this is the thought process I go through when I'm troubleshooting. I want to know what I need to test and what I can avoid testing right now, because I can test everything if I want to, but I'm working in a shop environment where time is money. And if I can do this fast, then I'm going to make more money, okay? So what I'm saying is, based on the fact that you guys smell fuel, is telling me that I have injection pulse, is telling me that I have a good input, and I don't need to check the crank sensor signal or the distributor pickup. I'm going right to the ignition coil, okay? And I think the next step is to check for control on the coil. On this diagram right here, guys, my ignition coil. So I need this thing to fire. This is the guy that's not making spark. The center wire on this diagram is the one that spark comes out of. For this to create spark, it's using magnetism. And what we're doing is creating a magnet, we're collapsing that magnet, and we're inducing voltage into a coil, and it produces spark. How can I make that simpler than that? This is where your basic electrical class comes in. You guys need to focus and pay attention when your teacher talks about electron flow, and he talks about magnetism, and he talks about mutual and self-induction. All of these terms apply here. I'm not going to go down that path for you guys. We'll be here for hours if I do that. If I had you for basic electrical, I would probably refer you to this case study so you would have some visual perspective, and then when we're going over it, then you can have that visual and apply it to the theory. Make sense? You guys will be able to do that. That will be a bonus for you guys when you get to that class, to pay attention to those subjects. So I'll do this quick, I think. There's a winding inside of here. This dark green yellow, let me just look at this for 1 second. See that right there, fusible link? It says F-U-S-L-I-N-K. That's a fusible link. That tells me that's my power feed for this ignition coil. So I have power coming into my coil here. That same power is also going to my distributor right there. and that same power is going over to a radio capacitor. That's for noise. Got it? That's my feed side of my coil. The control side is the dark green and yellow, and that would be this wire. And this part here is going to be for my tachometer, and it's going to be probably some kind of input to the computer. I'm not worried about this for our troubleshooting procedure. I'm worried about this one, which is inside of this ignition module, this TFI module. So let me simplify this for you. Here's what we got. Just get an area I can draw. We have a power going into a coil, and it gets switched on and off the ground. That's it. The switch that I drew up here is a transistor. It's an electronic switch with no moving parts. For you guys right now, aliens made that. How it works is irrelevant. Does not matter at all. Okay? I just need that switch to turn on and off. When this switch turns on, it closes, and we now have current flow through the winding. So what happens is these little electrons will start traveling through here, and as they go through this coil, they will produce a magnetic field. When you put wires together and wrap them around, it intensifies the magnetic field. So in the whole circuit, we actually have a magnetic field around the entire wire, including on its way to ground. That same magnetic field all the way through. You guys follow that? All right. Can I put a tool on this coil that measures that magnetic field? That's what I want to do. I wouldn't be asking you that if we couldn't do it. That's the test I want to do. So I'm going to put this tool. It's called an inductive low amp probe. It's a device that I'm just simply going to clamp around this wire or this wire. Doesn't matter. Either one. I can go on either side. What I want to see is current flow on this ignition coil. Make sense? Questions? Jason, go ahead.
So with those wiring diagrams, like, is the color coding universal to every vehicle?
No, not at all. Good question. Good question. If that didn't pick up, Jason asked me if the wiring diagram colors were universal, and they're not. Every manufacturer is different. There are some common wires. For example, black wires are generally grounds, and red wires are generally powers. But Honda, for example, likes to use black wires for powers, and so we can't make that general rule. How do you know what's what? Will come with time, and I'll teach you that more. These guys can attest to that. Being in my class, you learn more about how to read a diagram, and every time we do one of these, it helps you because we know what can be shared and what can't be shared and what have you. All right, so I want to see current flow. Questions on this? I want to see current. Now here's the thing with this. That switch, this switch right here, it doesn't just stay closed. It actually opens and closes back and forth. Pulses on and off. Every time a cylinder fires, that thing should be pulsing on and off, because once I make this field, I need to collapse the field. When does the field collapse? When the switch opens or when the switch closes? Opens. Very good. But I need to close it first. I need to build the field, then I open it, I collapse the field. What do we get? Spark. Okay, that's all we're doing right now. Everybody good with that? So that's one test that I want to do. I don't know if I necessarily want to start there, because as I'm talking to you guys, I'm thinking about one other thing that might be actually easier, and that would be a simple power feed test. Which wire do I want to check for power for on this ignition coil? My red one or my green one that I drew? Right here. Which one of the two is my power feed? Red one. Can I take this wire right here with a test light and just see if I got power? Wouldn't that change everything for us too? I want to do that first. We'll leave the scope out of this and try to keep this as maybe low tech as possible. Let's do that one. Let's do that one next. Just a simple power feed test. Okay? Listen, guys, really important when you're doing testing like this. Can everybody see what I'm doing? I have my test light connected to ground. I want to test it on battery positive before I do anything else. What's that tell me about my test light? It works. And what's that tell me about this ground? it's good. So I don't want to touch that now. Leave that alone.
Is there a certain type of test light they should have?
Good question. For this particular test, Randy just asked me if there was a certain type of test light that you guys should have, and that would be yes. But for this application and this particular test, it doesn't matter, Randy, because I'm not going to be doing a cranking control test. I'm just doing a key on battery voltage test. You guys have LED test lights that came with your test kit. You definitely want to get yourself an incandescent type test light. That's the one I'm using right now. For this test though, you can use either one. And with the key on, I should have power on both sides of this coil right now. Let me just back probe it. All right, how's my feed on my coil? So it's not something super simple. Let me just back probe this one too. Yep, on both sides. At this point, I'm going to connect the coil wire. Oh, something I forgot to tell you guys is whenever this car died on him, he replaced the coil and it didn't fix anything. So at this point, looks like we're gonna break out the scope, but I can show you one more test. And this is the one, Randy, where we absolutely want to have an incandescent test light for. I didn't take any of the wires off except for the, oh, your question was, did he put the wires on correctly? That's a good question. If I had wires that were off on the cap, I would still have spark going in. So the wire positioning right now is irrelevant. The fact that I have no spark coming from the coil tells us we're not worried about that. Make sense, Jason? Yeah. Okay. What I'm worried about is on this coil, it's called control. You know the switch that I just described to you, opening and closing? What I can do, let me go back to my diagram real quick, because it would help to know colors. Or no, you know what, it doesn't matter. I'll show you both. What I want to see, we'll go to this one first. All right, I'm gonna crank it, we'll watch it. I'll talk about the test in a second. I have the key on still. Okay, now I'm switching over to the other coil wire. They should both be lit. Cranking it. This should be the control wire. The other one should have been the power. I'm not positive about that though. Okay, let me ask you guys something. Did they look the same? Did they look the same? This is an important test. I'll do it again if we're unsure. Should I do it one more time? I want to know if they look the same. Jason, what do you think?
The light was brighter the first time.
Was it brighter
Yeah.
on one than the other? Watch it again. I'll do it one more time. Let's look at it. I'll start with this one this time. It got a little dim, and that was from the starter current. Watch this one. Okay, so yes, you saw some dimness going on there, right? The reason the light dimmed is when I crank it, the starter's drawing 150 to 200 amps of current, and what we're doing is we're lowering battery voltage. So it is normal to see the light dim when the starter engages. My question is, did they look the same? They both were bright when I started, they both dimmed when it cranked, and they both got bright again when I stopped cranking. They looked identical to me. It's all related to the starter motor. That brightness and dimness is related to the starter. We're good. But what this tells us, guys, is this, and I'll let you guys break here, because I at this point, I need to set up my scope and my amp probe. I want to see what kind of control is here. And then we're also going to look at that input that I said we don't need to look at, because I know we smell fuel, but I need this input for this to work. Okay, I need to know if my input's bad or my module's bad. That's kind of where we are right now. I know the coil's new, so chances of it being a bad new coil are slim to none, but we still need to check it. Here's what this test just told me. I put my test light here. I put my test light here. Test light was the same on both, which tells me that isn't moving. If that switch was opening and closing like it should be, this light would have flickered on and off. So the test that I just showed you tells you your coil is not your problem. Our problem is this way. What does this need to work? I need powers I need grounds, because this is in a module, and I need to have an input. That input is going to be a square wave that feeds into that tells that thing when to open and close. Make sense?
So now you're past the battery, you get power to the battery and you're past the switch, you're moving down.
That's right. I'm past all of that. That tells me, Jason, very good, my feed is fine, no problem. My feed into the coil is good. It also tells me that the winding of the coil is at least intact. It tells me that my control, this is called my control wire. It tells me that I have no control. There is a variable to this that I talk about with my class, and that's a shorted primary winding. I don't anticipate that because the car didn't start, didn't have spark, and he put a coil in it, and guess what? The car is not starting and we have no spark. So what are the chances we built in a brand new shorted coil? Slim to none. What I'll do for you guys, if you watch this later, make sure that you guys read, and this is for you guys, make sure you read the description of this video. And what I'll do is in the description, I'll post links to other videos where I've done control testing. I'll put one in on a Chevy truck that has a shorted winding, that the light's not flickering. I'll do one on a Subaru that I'm showing you the light's flickering. I'm using this as direction, as a guide. So make sure that you guys, when you're looking at this later, read the description of this video. I'll post other links that'll help you understand some of these concepts. Okay, I'm gonna set up, while you guys are on break, I'm gonna set up the lab scope and the amp probe, and we're gonna go a little bit further. What this is looking like is either a module or a pickup problem, okay? All right.